Hello, beautiful humans. Today we are going to talk about how we can use trig to solve for missing parts of oblique triangles. So oblique meaning non-right, so we have no right angles, so we can't use the rules of right triangle trig that we talked about last lesson. So this is a new rule. It's special because we can use it on non-right triangles. Okay, so what is it? Law of sines, again, allows us to solve for a missing part of any triangle as long as we're given a certain set of information. So we can be given angle, side. So this should bring you back to like your triangle congruence properties. So two angles and then a side, or angle, side, angle. That'll work for law of sines. You can also have side, angle. So notice in our triangle congruence properties that you learned, side, angle, if you can write it in reverse order, is a potty word. No potty words allowed, right? But actually, this is a great idea. The law of sines actually allows you to use that idea, but because it doesn't pin the triangle in a specific way, we call it an ambiguous case. What that means is there's actually two potential triangles, one with a smaller angle, one with a bigger angle. So we'll look at that in just a second. But if you notice that you're given side, angle, right, then you really need to pay attention, make sure that you are checking for both possible solutions. So when you look at this image here, right, so what we have is we could have that angle A that would be an acute angle, right? So angle A could be acute over here, right? Or we could actually extend this leg out like this, and angle A could be over here. And that would be a different angle measurement. Again, it's still acute, but notice this C angle would also change given that information. So when you just have two sides and one angle, we don't have a definite specific triangle. So your triangle congruence property should remind you of that. But we could have a triangle. We just don't know which one. Okay, so how do we use this? Well, basically, law of sines tells us that there's a specific ratio between sides and the sine of their angle. So if we have angle A, we're going to use capital letters for our angles, and we're going to use lowercase for our sides. So if you have a capital A, that means the angle A, and the side is always going to be opposite it, not touching the angle. So we have angle A here is opposite side A, angle C will be opposite side C, and angle B will be opposite side B. Also, these are ratios. So remember that ratios can be written in any order as long as you keep your proportions consistent, right? So what I mean by that is often you will see it written as sine A over A is equal to sine B over B. And that's actually how I typically do it. It really doesn't matter because we're going to cross multiply to solve. So as long as you're consistent, doesn't matter. So either way you prefer is fine with me. Okay, so let's look at actually using this information to solve. Couple things to keep in mind that you're going to need to remember. Remember, all triangle angles add to 180 degrees, right? So that's our triangle sum theorem. It tells us that all triangles will have angle measurements that add up to 180 degrees. So that's really important because you'll notice we have to have an angle and its opposite side in order to complete our ratio. And the only way we can solve for a missing piece is if we have a completed ratio. So you always have to have an angle and its opposite side in order to be able to use law of sines. Well, right now, the side I'm given is opposite this angle over here, B. I don't know what that angle is, so I need to solve for it. But I see here that I have two angles. So this is an angle, side, angle situation. Notice we can use law of sines when we have angle, side, angle, and it is not an ambiguous case. Okay, so what are we given? We're given angle, side, angle. Always good to remember what you're given so that you can alert yourself to that ambiguous case. And we can actually solve for this missing angle. If we take 180 and subtract 51 and subtract 39, we'll find our missing angle, which in this case happens to be 90. So this is a right triangle, which means you could definitely use right triangle trig on this. But I'm going to show you how law of sines works and prove to you that it works because you can check it using your right triangle trig. Okay, so what we now know is we have a angle 90. So what we're going to do is sine of that angle 90 divided by the side opposite, which has a measurement of 27, is equal to, well, now it just depends on which side you're solving for. Let's go ahead and solve for this side over here, which is A, opposite that angle A. So we're going to say is equal to sine of 39 all over A. And then we're just going to cross multiply and solve. All right, well, let's think about what we would do if we were using right triangle trig with this angle A here. We would do opposite over hypotenuse. That's the given information there, right? If we wanted to solve for A. Well, that sounds like sine to me. Sine equals opposite over hypotenuse. So that would be A sine, try again, so now sine of theta would equal, which we have, get it together for now. Sine of 39 is equal to A, the piece we're solving for, divided by 27. All right, well, when you do sine of 90, you're going to realize it's just 1. So when we cross multiply, we get A sine 90 equals 27 times the sine of 39. Well, sine 90 is equal to 1. Check it in your calculator, but it is. So we know that this is just A over here is going to equal 27 times the sine of 39. Well, look over here. If we're going to go ahead and solve for A here, we'd multiply by 27 on both sides, and we get 27 times the sine of 39 equals A. Hey! So notice, doesn't matter if you're using law of sines or right triangle trig, you're going to be able to solve this problem. And now this is just a job for your calculator. So you're going to take the sine of 39, make sure your calculator is in degrees, and multiply by 27, and we get that A, did I solve for A here? Oh, no, I actually solved for the other one in my work. So I actually solved for side C first. Anyway, so I'm going to show you that one. But you can use this to double check what the side of A is. All right, so when we do C, now we're going to do sine of 90 over 27 is equal to the sine of 51. Notice we can do this for any angle, divided by, let's call it C, right? Because we want to solve. Okay, again, we know sine of 90 now is 1. So this is just, when I cross multiply, I'm just going to get C on the left-hand side. C equals 27 times the sine of 51. And so when we actually plug that into your calculator, you get that side C is about 20.98. Okay, once you have that side, because this is a right triangle, you could use Pythagorean Theorem to solve for C, or you could use that law of sines we already set up and solve for side, or rather side A, solve for side A. All right, give this one a shot. Start by asking yourself, what is the given information? So the given information here is angle, side, angle. So we have two angles and an included side. Again, I need that other angle to be able to use law of sines. So I'm going to take 180, subtract 101, subtract 63, and we get that this angle measurement must be 16. Okay, so now I want to solve for a missing side. Let's go ahead and solve for our side C again. Boop. All right, so if I'm solving for side C, I'm going to do the sine of 63 over C, because that's what I want to solve for, opposite angle and sides, is equal to the sine of, I have to use sine 16 and its opposite pair of 9, because that's the only ratio I can complete. So now we need to cross multiply. 9 times the sine of 63 is going to be equal to C times the sine of 16. Now in this case, we're actually going to have to calculate these, because neither of these are going to be equivalent to 1. So you're going to grab your handy dandy calculator, and we're going to take 9 times the sine of 63. 9 times the sine of 63, which gives us 8.019 blah, 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 right? Keep that in your calculator. Always important when you're doing math like this to store as many values as possible by keeping them in your calculator. Then we're going to need to divide that value. We're going to divide that value by sine 16 to get that c all by itself. So divide by sine of 16. So in your calculator, divide your answer, again, keeping that value, divide your answer by the sine of 16. And we get that our side C is about 29.09. Side C. Okay, go ahead and see if you can also solve for the other side by using this strategy. All right, how about this one? Okay, so again, this time they actually gave us our opposite pair, right? So we have an angle and an opposite side. That's convenient. What else are we given? Well, we're given side, 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 and an angle, right? Plenty of information here. We have lots of info to go with. So now we're solving for an angle, though, notice, because I've given all my sides. So let's solve for angle C first. All right, so we're going to set this up. Sine of capital C, because now I'm solving for an angle, over its opposite side of 21 is going to be equivalent to sine of 88, the given angle, over 26. Again, we always have to have a completed ratio to be able to use law of sine. Now we cross multiply 26 sine of C is equal to 21 sine of 88. Okay, so I'm going to take 21 times sine 88, and then I'm going to divide that value by 26. No, I'm not. I'm going to divide by just 26. Get it together. And then we're going to have sine C left over on the right-hand side. So 21 times the sine of 88. Again, double checking that your calculator is in degrees because you're going to get weird answers if not. Okay, so I get sine of C equals about 8.807. Okay, now if I'm solving for an angle, I have to use inverse trig. So remember, inverse trig is the inverse operator to undo sine. We're going to do sine -1. So we're going to undo this. We're going to get C is going to be equal to sine -1 of 0.08 or 0.807, blah, blah, blah. Again, I'm going to keep that in my calculator. So now I'm going to do second sine, or sine to the -1 of my answer, storing those values in your calculator to the best of your ability. And we get that angle C is about 53.8 degrees. Now this one's really easy to solve for B, right? You can simply take your 180, subtract your 88, subtract your 53.8, and you've solved for angle B. All right, same given information here. We have angle and we have side, side, side. Plenty of information. Okay, so what we want to do is, what we're going to do is check out our opposites and our sides, right? I got a little distracted here. I was thinking about, why haven't I done an ambiguous case yet? Well, if you have the triangle, there is no ambiguous case, right? Because you can see the triangle that's given. So there won't be ambiguous cases when you can actually see the given triangle. You'll have to look for ambiguous cases when you're not given the actual triangle. So we'll do that next, but that's where my brain went. Okay, so we're going to do sine of our angle A, which is 103, divided by its opposite side of 26, is going to be equivalent to sine of, let's go ahead and solve for angle B this time. So now we're going to do sine of B divided by 24, its opposite side. Okay, so cross multiplication gives me 24 times the sine of 103 is going to be equal to 26 times the sine of B. To isolate that sine B, we're going to divide by 26 on both sides. Now we have 24 times the sine of 103 rather, and we are going to divide that value by 26, and we get that the sine of B is about 0.8994, etc., etc. Now we have to use inverse trig to isolate our B, our angle here. So we're going to take sine -1 of this whole value here. Again, keep that. You're going to put answer in your actually, I think it's A-N-S, okay, anyway, answer, that'll insert the answer from the previous problem from your calculator. So we're going to take arc sine, or sine to the -1 of that 0.899 business, and we are going to get that angle B is about 64.08, about 64.08 degrees. Okay, again, triangle sum theorem will help you solve for the other missing angle. All right, here's where we really need to pay attention and look for those ambiguous cases, because I don't have a triangle to base my information off of, so I need to really pay attention to that that potty word, that side angle, or in reverse, angle side. Okay, all right, so what we want to do here is just indicate what information we're given. We have an angle and we have two sides. Okay, so let's go back to our ambiguous situation. We have an angle and two sides. Now, if the angle's included, that's different, right? If the angle's in between those two sides, we're actually going to use law of cosines, which we'll learn next lesson. But currently, the angle is it included or not? So let's find out. So remember, included would be between. So remember, angles and their opposite sides are always together. So if we just did a rough sketch, really doesn't matter. 84, let's give an approximate to 84 degrees, right? So if I just said, okay, that's really close to 90, maybe that angle looks like that. So I'll put this 84 here, which means, again, I don't know how these, how this triangle looks, but it means side B over here would be 9, right? And then side A could be either one of these. This could be A or this could be A. I don't know. But I do know that means I have a side angle situation, because my opposite side is, I don't have that included angle, right? Okay, so this is ambiguous case. I'm going to have to solve for both possible triangles. All right. So what we're going to do is just set this up exactly as we would previously, but then we just need to account for the fact that that angle could be, it could be swung out, right, based on that image above. So I'm going to show you what that means in just a second. All right, so we have sine of 84, and we're going to divide that by its opposite side of 9, and that's going to be equal to sine of A. Again, that's what we're solving for, because we only have our opposite side of A, so we have to solve for A here. All right, so now we're going to just solve like we did in the last several problems. We're going to do 18 times the sine of 84 is equal to 9 times the sine of A. We're then going to divide by 9 on both sides. All right, so we get 18 times the sine of 84, which is 17.9 something. Then we're going to divide by 9. Then we're going to arc sine that, right? So we get 1.989 blah blah is equal to the sine of A. So now we're going to do arc sine, or sine to the -1 of that value, right? And that'll give us the value of A. So arc sine of my answer, and my calculator says error. Uh-oh. All right, couple things. If your calculator says error, step 1, double check that you are in degrees and not radians. Then double check your math, that you didn't do anything funky. Then, if that's the case, if you get an error out of this setup, it's not a triangle. It's not a triangle, right? That angle at its opposite side and the other side of 18 cannot be used to form a triangle. Won't work. There is no such triangle. So when you get an error out of your calculator like that, it means, hey, there's not actually a triangle that has those measurements. That doesn't exist. So moving right along, you just say not a triangle in that situation. All right, what's the given information? We have 2 angles and a side. Okay, 2 angles and a side is definitely not our ambiguous case. So now we're just going to go ahead and set this up and solve. All right. So we're going to start with C, because that's the ratio we have completed, right? So we're going to do sine of 13 degrees divided by 9 is equal to sine of 22 divided by the side A that we don't know. Why do I always have 9s and A's? They all look so similar. I need to be better about writing my A's. Let's try this again, make it more A-like. Okay, so we're going to cross multiply, and we get A times the sine of 13 is equal to 9 times the sine of 22. So we're going to take 9, clear because I still have my error there, 9 times the sine of 22. And then we're going to divide by sine 13. Notice this time we're solving for a side, not an angle, so no arc sign required. And when we do that, so I also divided by sine 13, divide by sine 13. And of course, that's this entire thing being divided by that. And we get approximately 14.99. Again, we could then use another ratio to solve for our other side and angle as needed. I mean, we'd have to solve for the angle using triangle sum theorem, but then you could use law of sines to solve for the other side B. Okay, here we go again. Okay, now I'm given side angle. Oops, and I have an opposite. So this is my ambiguous case again. So again, I want to check for multiple options here. In our first example, we got an error. It was not actually a triangle. So in this example, let's see if we have to solve for both angles. All right, so again, we set this up with the information we're given. Sine of 70 over 25, its opposite side, is going to be equal to sine of angle C over 26. Okay, so I'm going to cross multiply 26 times the sine of 70 is equal to 25 times the sine of C. Sine 70 times 26. And then we're going to divide by 25 on both sides because we want to isolate our angle overall, right? So divide by 25, and we end up with 0.977, blah, 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 is equal to sine of C. So now we're going to do sine to the -1 or arc sine or inverse sine of 0.977, blah, blah, blah. All right, so now we're going to arc sine that business. And we actually get an answer this time. So we get that the measure of angle C is about 77.7. Okay, all right, but we said this is the ambiguous case. So what we know, if we were to draw this, let's say this is, I don't know, 70 degrees. There's my A of 70 degrees. And then it's opposite my side A. Well, if I have a wider angle over here, maybe my side A is more like, this is not obtuse, obviously, can't be obtuse. Whoop, that would not work out triangle-wise. So we have then a 77, right? Okay, but it could swing the other direction, so we have to account for that. It could actually be a really teeny tiny angle. So how we do this, it's actually pretty easy. All we have to do is take 180 and subtract that option, because right now we know two angles, right? We have a 70 and a 77.7. So when we subtract from 180, we find our missing one, but we actually don't know which angle is associated where, because we don't officially know where this side C is. So we have to account for both, whether it's in this location or this location, right? So we're going to take 180 and we're going to subtract 77.7, and that's going to tell us what the other option would have been. So you take 180, you subtract your 77.7, and then you realize that you could have also got an angle. Oh, and I said really small, but it could have been really big rather in this case. Could be 102.3. All right, well, double check that. Go ahead and plug it in and see if those are in fact equivalent. So what that would have to mean for this to be true, the sine of 77.7 and the sine of 102.3 have to be the same. Otherwise, this wouldn't work. So go ahead and check that in your calculator. Is the sine of 77.7, and again, these are approximate, so approximate, equal to the sine of 102.3? Double check it, see if I'm right, see if you agree. All right, last but not least, we have another angle side situation. Ooh, but this is an obtuse angle. How many obtuse angles can you have in a triangle? One and only one. So this kind of pins this triangle in a unique way, unlike our last example where the given angle was an acute angle, right? So if you have an acute angle, it opens up a lot of options for the rest of your angles, right? But if you have an obtuse angle, there can only be one and only one. So this isn't actually ambiguous because it pins it in a different way. So when we solve for this, there will only be one potential option. So we're going to do sine of 105 over 23 is equal to sine of, we're solving for A, over 14. We're going to go ahead and cross multiply here. We're going to do the sine of 105 times 14. We're then going to divide by 23. So what I just did was 14 sine 105 equals 23 sine A. And then we would divide by 23 on both sides. And we get 0.587 blah, blah, blah is equal to the sine of A. And then we have to arc sine. Sine -1 of 0.587 blah, 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 blah. And we get arc sine 36. Whoop. Stop. Down. 36. Angle A is about 36.01. Okay, so again, let me remind you what I was saying before, why I know I don't have to worry about the other option here. If we go ahead and take our 180 and we subtract our angle of 105, right, we have 75 left over. Well, when you take 180 and you subtract 36, you'd have 144. That's not going to make my 180 rule work, right? So all angles in a triangle have to add up to 180. 36 is the only one that's going to work here because if I add 144 and 105, I have gone over, my friends. This is not going to work out. So there is no other angle option. Because we have that obtuse angle, it's kind of preventing me from having the big angle option here. Hopefully that makes sense. Reach out with questions as needed and have a wonderful rest of your day.